going to show you first, just a reminder, how to count around the unit circle. If you put a line here, I'm just going to start as a reference point. Okay. If we go around the unit circle, I'll use this video. If I go around the unit circle all the way, okay, how far have I traveled? 360, right? Oh, okay, I'm sorry. We're going on degrees today. Yes, 2 pi and 360. What would happen if I traveled around the unit circle twice? How many degrees have I traveled now?
720.
720, 360 and 360 more, right? Okay, well, knowing that, okay, I want to just practice counting around the unit circle again. So if I travel around the unit circle and I start here, and I go over and I stop, I'm at 90, correct? Okay, and then if I keep going to here, where am I at now? 180. If I keep going, I'm at, okay, if I keep going, I'll be at 270. Technology, I'm so good at it. Okay, and then back to all the way up at 360. Right? Where then would a 50-degree angle fall? Right, it would fall kind of in here somewhere. What quadrant is that? 1. What if I asked you where a 140-degree angle would be? 140 would be somewhere here, correct? In other words, I would start here. It's a wide angle. It's 140 degrees, isn't it? Do you all see what I'm saying? Okay, so that maybe will help you guys with what we're going to talk about today. So in your journal, switch gears here. In your journal for today, label it angles and degrees measure. Angles and degree measures. Okay, we can go, the direction we were just counting on that unit circle was actually counterclockwise, right? We can go counterclockwise to generate positive angles. But you can go clockwise to generate negative angles. Right? In pre-AP, actually, they had to take the unit circle and they had to go around it and label everything positive. They had to go the other way and label everything negative. But it's not any harder, you just count the other direction. Alright? So we're going to call them directed angles because this is which direction you're going to go. So we're going to write the definition, directed angles. And directed angles have two things. They're either a positive direction or a negative direction. Here's a circle. And you'll notice when I started counting, I started at 0, didn't I? Okay, on the x-axis, the positive side. They call that the initial side. In other words, initial meaning where you're going to start, right? And when you stop, where I ended up, they call that the terminal side. Think about it like a bus stop, right? Where the bus stop, it stops. It's called a bus terminal. Okay, maybe you think about it that way. It's where it ends. Okay? Now then, positive angle. We talked about positive angles. Now, it's kind of backwards, but when we were going, if we start here in the unit circle, we're going this direction towards the left. Is that clockwise or counterclockwise, actually? Yeah, it's kind of bizarre. A positive angle is generated by a counterclockwise direction. Okay? So an angle generated by a counterclockwise rotation. In other words, to create a positive angle, okay, watch this because the only way I can explain something to you. Okay, we start at 0 and our direction, watch my arrow. It goes this way. See how I drew a little arrow? That's motioning for my arrow to open up this direction, which creates another angle. Do y'all see how I did that? Okay, they call that a positive angle. Now then, if we go the other direction, what do you think it's going to be called? A negative angle, right? So add that in. And it's an angle generated by which to me is backwards. Like we usually associate them the other direction, but you know why would math want to be normal? Okay, so watch me build it so that you can see it. If I start here, which is on the x-axis, okay, watch my arrow. Instead of my angle opening up this way to be positive, we're going to count around the other direction. So we're going to count down. So my angle opens up negative. It's a negative angle. Every time we started counting in the unit circle, where did we start? We started when we were doing degrees. Good, we started at 0, didn't we? Well, that has a special name, of course, right? When you're trying to build an angle from the unit circle, okay? And we did that all day yesterday, for example, here, okay? If I want to build a 45-degree angle, right, I do my first, my start here, my end here, correct? What if I wanted like a 130-degree angle? I would be this direction. I'd start here and end there, start and end, correct? So all the angles that we study, even though this is obtuse or acute or anything, even if, say I wanted to go really far, all the way to quadrant 3, look how wide this angle is. It starts here and goes all the way to there, doesn't it? It's a big wide angle. Okay, but every time I started at this spot, when you start in that spot, it's actually called standard position. Standard position. You, let me draw one for you here. Okay, so for example, in standard position, if I started, you always start your angle here. It doesn't matter where you stop, okay? This is your starting, and this is your stopping. And sometimes they'll call it, I motion to say so I know I went that direction, and they'll call your angle theta. Y'all remember that? That's that little circle with the line through it. You did that in geometry, theta. So once or twice since then. And remember that they call this the initial. The initial side must be on the positive x-axis. That's what standard position is. She's showing you I'm starting your initial here on the positive x-axis. And remember again, where you end, this thing over here is called the terminal side. Okay? Here's another example of a standard position angle. I'm going to start here, and we're going to put this in the quadrant. Okay, this one we went the other direction. We're going to go this way. It's a negative angle. But either way, you have to start on the x-axis. Those are standard position angles. Another really special angle. Already, can I touch it? Not yet. You know, when you guys have, when somebody has 4 kids at once, what are they called? Right. Quads, right? Or quadruplets. So the quad comes from 4, right? So that's going to help us remember the next part. If you have something called a quadrantal angle, a weird word. I know, that's why I started with something you're familiar with, like a quad, right? Quads. So it's quad, okay? But quadrantal. Quadrantal angles. And I think of them as 4s because, let me explain what they mean. An angle whose terminal side, that means the side that stops, right, lies on an axis. Okay, yes, very good. And if you're asking me, well, what made you think quad and 4? Okay, how many stops are there? If you just look at this, 1, 2, 3, 4, right? There's 4 stops. So it's like breaking your circle into 4 pieces. If your angle lands on an axis, 1, 2, 3, or 4, one of those stops, one of the 4 major stops, is called a quadrantal angle. It has a special name, in other words. If you land on an axis, so if you land on, what, 90, 180, 270, or back to 360, it can be closed, it can be a complete circle. Okay? Now, to look at that, then let's draw the first quadrantal. Here's one. It starts here always and would end here. They call this theta. Do you understand the arrow is to delineate which direction I'm going? Started here and I stopped there. Does that make sense? That's a quadrantal angle. Yeah. Yeah, if it's in standard position, good question. If it's in standard position, it always starts there. And you can either open up, going positive around the unit circle, or open down, going negative around the unit circle. Okay, the next one. What if I don't stop at 90? What if I decide I'm going to start here at 0, but I'm going to watch my arrows? So this will make sense if you watch it. I'm not going to stop at 90. I'm going to keep going. I'm not even going to stop at 180. I'm going to stop at way down here at, what's this one called? I'm going to stop at 270. Good. It's also a quadrantal angle. Okay? Now the next one. If you watch me build it, it will help. So I'm going to start here. Okay, I've already stopped at 90. Have I stopped at 180 yet? Okay, so let's open up here until we get to 180 and stop. I'm going to stop at 180. It's another quadrantal angle. A little circle, the line through just means theta. The arrow is to show you which direction you went. Did you go a positive direction, which is counterclockwise? Negative, which is clockwise. Right, now here's the directions. Sketch the angle and tell what quadrant if quadrantal, then say so. Sketch the angle. Tell me what quadrant, and if it's quadrantal, say so. So the first angle I want you to sketch for me is a 45-degree angle. So you have yourself a little grid here. Remember what I told you about where it starts. So it's standard form. Standard is going to start here. Okay, and we know that this stops at 90 degrees. So are we going to go all the way to 90? No, it's going to fall somewhere here. Right, so you're going to start it and show me where you started at. Started at 0 and I went to the 45 degrees. Right? Okay, and what quadrant is that? 45-degree angle. And what quadrant am I in? Quadrant 1. Go to the next one. Negative 135 degrees. This one's special because I can't go the same direction I did A on. I gotta go the other way. Count backwards. Negative 90, negative 180, negative 270. Try it. You get it right. Okay, look up here for a second. If I'm going to go negative, I need to go this direction, which means I'm going to call this negative 90, negative 180, negative 270, back to negative 360. What if I keep going? Can I keep going? What's 360 and 90 more? Well, 360 and 100 more is 460. So 360 and 90 more is 450. What if I keep going? 450 and 100 more is 550. So I need 5. I can just keep on and on and on, can't I? Right? But that's not what they asked me to do. I was just showing you. He wants me to stop at negative 135. So negative 135, if you're not sure, I'm going to start it off here. You can label it. Negative 90, I'm not there yet. Negative 180, oh, I'm between those two numbers. So I know I'm going to fall here, which means I started here. Now, look at my arrow. Started here and landed there. This is negative 135 degrees. What quadrant do we fall in? 1, 2, 3. C. How about 250 degrees? If you're not sure, you can watch me. This will be 90, this is 180, and 270. So I'm going to travel all the way till I get to here. It's 250 degrees. What quadrant did I fall in again? 1, 2, 3. You try negative 290. Go the other direction. Count if you need to. Write them down. Negative 290. Start here. Negative 90, negative 180, negative 270, and negative 360. So where did I fall? Between these two, right? Here. Now watch my markings. Okay, you ready? Look at me. I didn't go up. I went the other way, which is why it's so big. If I'd gone up, that'd have been like between 0 and 90, like around 45. It's not 45, is it? So you have to tell the person you didn't go that way. That's what the arrows are for. I went this direction, and it's called negative 290 degrees. Do you see the purpose of the arrows? Because that could have been a 45, couldn't it? Okay, the last one like this. Oh, I forgot to say what quadrant. What quadrant is that in?
1.
1. Sorry. Got sidetracked. Okay, you ready? 540. It's a negative 540, so you have to go backwards. Negative 90, negative 180, negative 270, negative 360. I'm still not there. You know, hang on. You have to show me then. I started here. Okay, watch your arrow. I went this way, didn't I? And I looped all the way around and back to where I started. Correct? Is that enough? So now, negative 360, negative 450, and negative 540, and finally there. So keep going all the way to here. So what are we going to call that? What do we call it? Quadrantal. Quadrantal. Is it easy? It's not too bad. Here's the next one. We should sketch this angle. But we don't have a calculator, which I'm going to assign you a number to a calculator today, but sketch the angle. Here's A. What if I told you 1/9 of a counterclockwise? Yep, I heard it. I'm going to go 1/9 counterclockwise, right? Well, how much is the whole circle? Yeah, it's 360, right? So I want to go 1/9 of 360. Well, then to find it, I want 1/9 of means times 360, which is 360 over 9. We don't have a calculator, but if you did, 360 over 9 is 40, right? 9 goes into 36 4 times, so it's 40 degrees. So I want to, that's all. It's that simple. You want a 40-degree angle. Sketch me one. It's 0. Oh wait, counterclockwise. Be careful. Is that a positive or negative?
Positive.
Positive. It's backwards in your brain. Counterclockwise plus positive. So here's 90. So 40 would be, start here. 40's here. And make yourself a little mark so I know you went the correct way. Okay, B. How about 1 1/3 of counterclockwise? So instead of going positive, which direction do I need when I want to count? Oh, I'm sorry, that should say clockwise. I'm sorry, 1 1/3 of clockwise. 1 1/3 of clockwise. Clockwise is negative, isn't it? So I want a 1 1/3
Could you make the negative 1/3?
of a negative 360. Well, it's going to be negative. So I want to go all 360, and then do I want more? Because I want 1 1/3. So is my answer going to, I'm going to have to go around more than one time, correct? So I don't know if you remember this, but times and a plus, this is the same as 4/3. Means times, so times negative 360. When you do 4 times 360 divided by 3, sorry, you get negative 480 degrees, which is what we thought, right? It's going to be more than, we're going to go around more than one time. Try to sketch that for me. Sketch negative 480. Show me your arrow, and you know to know which way you went. going negative. Start here. Make it all the way around and then back to here. So what quadrant is that? Quadrant 3. Alright, last part. Okay, coterminal angles. I'm gonna write all this weird vocabulary, but it's not hard. Okay, let me talk to you about something. Do you remember how we had to put the arrow so I know which way you went? Okay, because you could go up 45 and be a positive 45 degree angle, or you could come around the other way. It's kind of like a bus route that you're traveling on. If I'm traveling on my bus route and I'm going this way on the bus route, we call those positive numbers, right? If I want to stop right here on my bus route. But if I go on my bus route this direction, I can still land in the same spot, can't I? Which bus will get there faster, the black one or the blue one? The black. Okay, but are you still going to get to the same spot?
Yeah.
But you went a different way, so you're going to have to call it a different number. Okay, this is still bus stop 5, all right? It's the same location, but I could call it bus stop 5. I could call it, Lakeview Lane. Okay, I could call it, that's the house that Billy lives at. Right? It's the same stop. Okay, but that's kind of what coterminal angles are. They're naming the same bus stop. Okay, for an explanation point, with different names. So, for example, if I gave you 120. Oh, I didn't write the definition. I'm sorry. Let's write it. 2 angles whose terminal sides coincide, which just means match. When angles are in standard position. In other words, it's just 2 angles that overlap. So in a color, I'm going to draw me a 120 degree angle. That angle is 120 degrees. Right? Well, if I make a loop all the way back around, I stop at 120. Okay, let me show you the little arrow. Watch this. I'm starting my bus route. I stop at 120. And I make my bus route again. How could I call this another name? How could I get to it? 120 plus how much more to get all the way back? 120. And if I loop all the way back around and land back again on it. So a coterminal angle with 120, a positive coterminal angle, would have to make the complete loop again to land back in the same spot. 120 plus 480. However, okay, I could go the other direction too. Okay, which would be 120 minus what? 360. In other words, I'm at the bus stop. Instead of going around, adding 360 and landing there, I could stay here and go the other direction and land back. What's that going to give me? 120 minus 360 is a negative coterminal angle. What's the negative coterminal angle going to be? Negative what? 240. Those are your 2 coterminal angles. One positive and one negative. This is what the directions will always ask you. You try one for me. What if I told you 130 degrees? Find me the coterminal angles with 130 degrees. One positive and one negative coterminal angle. I would do 130 plus 360. And then I'll do 130 what? Minus 360. So that I'll get a positive angle that lands in the same spot and negative. Coterminal meaning the same. So one was 490. And then 130 minus 360 would be what? Negative 230? Okay, try a different type. What about negative 210? Negative 210 is already negative. It's okay. Go around the positive way by adding 360, and then go around the negative way by subtracting 360. See what happens. Coterminal angles are just another way to name the same spot. So negative 210 plus 360, and negative 210 minus 360. Yeah, I got 150 and negative 570. Is that what you got? Okay, the last one, a tricky one. What about 520? Think about 520 for a second. If I add 360, I'm really high. I'm at like 880. If I subtract 360, am I still at a positive answer? Well, how am I going to get, okay, so let's do that. So take 520 and subtract 360, and you get 160 degrees. How could I get a negative? Right, I could subtract again, can't I? Okay, because there's positive, they're the same stop. So then take 160 and subtract again to give you negative 200. Does that make sense? If you're over 360, you have to subtract twice. Your first subtraction will get you positive. Your second subtraction will get you a negative.